We're going to record the notes for today because we're going to emphasize the algebraic piece a little bit more than the one that's currently on YouTube. So the properties of math help us do mental math. So we saw that with, 5 times 28, you can do 5 times 20 plus 5 times 8. So again, these notes should be in your binder. You flipped them in the other day, but if you can't, we have some extras. But it also gives us flexibility when using formulas. So remember the area formula of a triangle? You might have initially learned it as base times height divided by 2. Now we're going to use the formula half times base times height, because that height might be an even number, and I can split that in half easily. So it's going to give us some flexibility with that. And now the thing we're going to add to it, and they help us simplify algebraic equations. Or expressions, not equations. So the first one we'll start with is this one here. If you look at it, for any number a plus 0 is going to equal a. Who can tell me one of the names for that one? Yes, sir?
Addition property of 0.
Addition property of 0 is one of its names. Does anyone remember the other name? Yes, sir?
Identity property of addition.
The identity property of addition. So we've got two names for this one. The identity property of addition, or the addition property of 0. Essentially says if I add 0 to something, it doesn't change the value. So with numerical expressions, it could help us because even if we're dealt with something that looks initially complicated, -6 plus 0, I don't need to deal with my negative positive rules because plus 0 means it's just going to stay -6. If I had something where within my expression, one number is going to be subtracted by itself at some point, they essentially cancel each other out. They're inverses. We've seen that term, inverses. So if I had 2.8 minus 2.8, it could be down the line, but we haven't officially taken notes on community property, so we'll put them next to each other to begin with. Plus 5.9. You don't have to dealing with all those decimal parts. You go, oh, this and this cancel each other out. And I'm left with the 5.9. But now the example that we're going to add that's a little different than what's on the online notes prior is that we might have some variables involved too. So 31.4 plus 7x plus 0. So if we were presented with that, we're going to, we can just drop the plus 0. We don't have to keep tagging that along if we're dealing with an algebraic expression. So it doesn't add a whole lot of value, but if you look for these sort of situations like that, 2.8 and somewhere else subtracting 2.8, that can sometimes make life a little easier, getting rid of things that cancel each other out, even in an algebraic expression. The next property we're going to deal with is that one where for any number a times 1 equals a. So that's another one that has two names. Who can give me one of the two names? Excuse me.
Identity property of multiplication.
Identity property of multiplication is one of the names.
Identity property of 1.
The multiplication property of 1. Yep, so it's similar. Multiplication property of 1. So for this one, the identity property of multiplication. Or the multiplication property of 1. So for examples for this one, we might have 6.45 times 1. And you don't have to set it up with multi-digit multiplication and deal with the shrooping and all that stuff. You go, oh, times 1. That just means that's going to go away. But similar to being able to cancel out those 2.8s with that addition and subtraction stuff, I could end up having 8 times and somewhere down the line, 1/8, and those will end up canceling each other out. Times whatever else, in this case 4 3/10. So when I have a number times its multiplicative inverse or reciprocal, those cancel out, and I just have the other stuff. So the 4 3/10 is all that remains because everything else canceled out. And then for a decimal example, 9 times y squared times 1. You just get rid of the times 1. Any number, anything times 1 is going to equal itself. So just leave it as 9 times y squared. So if you see a times 1 somewhere in the mix, or a number times its reciprocal somewhere in the mix, those can kind of just go away. For the next one, we have any number a. We have a times 0 equals 0. Who recalls what that property is? Yeah?
Multiplication property is 0.
The multiplication property is 0. So the multiplication property is 0. Anything times 0 equals 0. So the way that's helpful is even if I have a whole lot of stuff that's getting multiplied, if somewhere in there there's a 0, the whole thing. Don't even have to worry about multiplying the stuff in the front. So for an example here, I have 9.3 times 4.8 times 0. You don't have to start left to right. You can go, oh, it's got a times 0 in there. It's all multiplication and one of them is a 0. So the whole thing becomes a 0. If I have things that are going to multiply an expression, that zeroes out. 19 minus 19 zeroes out. So then this whole thing becomes 4 times 0, which is 0. We don't even have to write that middle step. You can see that 19 minus 19 is going to cancel each other out. I always debate whether or not we should put it in, but it's optional. And then for an algebraic example, I went through these the other day, made an algebraic example for everything. 3n times 37m times 0 times 2 multiplied by the difference of n and m. It seems very complicated. There's a whole lot going on there. But if I skim that whole chain of things that are getting multiplied, there's a 3n, there's a 37m, there's a 0. There's a 0. It doesn't matter what the rest of it is. Everything is multiplication. And this, after it's evaluated, is multiplication with the rest of it. So everything becomes 0. Alright, now you want to get to the ones that people get confused about, the names. Which one is it when you pair things up differently? See how well we've been practicing and learning. Yes, sir?
Associative.
The associative. Which one is it when a number was a multiplier on the outside and instead it's multiplying by each of the things that would be added on the inside?
Negative.
Nope, there was a number on the outside
Oh, distributive.
distributed and it got multiplied to the parts on the inside of an addition problem or a subtraction problem. What about the one where the numbers moved around, so now you can work with them in a different order of things?
Commutative.
Commutative. So those are the ones we're going to review next in the notes. Lily, come on. There you go. Go, 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 go. Go. Yep, here we go. Alrighty, is that where we need to be? Multiplication property is 0, and then after that is the a plus b equals b plus a. Yes, go. So this is the one, a plus b. Could be written as b plus a. Instead of adding a plus b plus c, I could add the a and the c first. Which one's that? Yes, sir?
Commutative.
That's commutative. So things actually had to move around to make them where I wanted them to be to do the computations. So that's the commutative property. So some examples for that. So some numeric expressions first. 9 plus 19 plus 8. Bless you. 9 plus 19 plus 8. I could add it left to right, and I'm hopefully going to get the right answer if I'm careful about it. But it's just a little bit easier if in my head I go, oh, I'm just going to put that 8 next to the 2 instead. And I don't typically rewrite it, but you can. So that's why I put it in the square brackets. You can rewrite it. The book rewrites it. As long as I know it's the commutative, because I made this essentially go over there and be next door to that. You know, I matched these two up instead. So I end up with 10 plus 19, which is 29. If I had done it left to right, that would have been fine. I would have got 21 plus 8, and then 21 plus 8 is 29. But instead, these two added up to make 10. That's just a little bit easier to deal with. If I have something like 1/2 times 37 times 4. Half of 37, don't know off the top of my head. Could take a little bit of brain thought to figure it out, but I don't want to. Because who can tell me what half of 4 is? Yes, ma'am. 2. So if I can instead go, ooh, it's easier to take half of 4, I'm going to do that instead. And again, the book would rewrite it. I'm going to do half times 4 times 37. But I'm just going to take half of 4, multiply it by 37. It's still not the easiest thing, but try to double 37. What do you get? What do you get when you have 37 doubled?
78.
Not 78. Think about 7 doubled, what it's going to end with.
Or 74.
Yep, a 74. Whoops. No, I almost wrote it wrong. So this is a prime example of where I typically use it, is in the formula for triangles, area of triangles. Now we want to have, well, we don't want to, but we now, as 6th graders, need to get comfortable with algebra. So now we're going to put in an algebra example. Actually, I got 2 of them. If I had 4 plus 6f plus 1. 4 plus 6f plus 1. I can't add 6f to 4, and I can't add 1 to 6f. What are the only things in here I can actually take care of adding? Yes, sir?
4 and 1.
The 4 and the 1. Again, your book's going to go and show the rewriting, making it 4 plus 1 plus 6f. I don't typically, I just go, oh, I can just add these two. And what am I going to get when I simplify that algebraic expression? By combining those constants. Yes, sir? 5 plus 6f, yep. Apparently I made a second example. Let's just go to town with these problems. Let's see. Oh, I know why. So I did 8 plus 3g minus 2. So it still has to be minus 2. Still consider the commutative property, even though it's not all addition. I can take care of 8, and I can take care of the minus 2. The real reason is because it could become addition by making it plus a minus 2. That's what you're going to ultimately be thinking about down the line. But if I have a constant here, and I have the subtraction of a constant over here, I can go ahead and do them even though they're not right next door to each other. So who can tell me what 8 minus 2 is? 8 minus 2. Yes, ma'am? 6. So this becomes 6, but then I still have to carry forward the plus 3g. So that one's a little bit trickier because the commutative property typically is only addition or only multiplication. But I can combine constants in this method if I remember that I need to subtract that certain amount. So that's a little bit of a special case. Now the next property is the one where I'm not going to change the order of them. They are next to each other, but they weren't supposed to be done until later. So instead of partnering them up at the beginning, I'm partnering them up later. Which one is that? Which property when I'm partnering them up in a different priority level? Yes, sir?
Distributive.
Nope, not distributive. Distributive is when there was a multiplier on the outside and it gets multiplied to each of the parts on the inside.
Associative.
This one's associative. Oh, it's tricky to get all these names straight. So this one's associative. So if I have three numbers, or, you know, a lot of numbers, whatever it might be, instead of partnering up the way you initially wrote it, I'm partnering them up different. That's the associative property. So for some examples here, we have 15 plus 17 plus 3. If I'm doing it left to right, like order of operation tells me I'm supposed to, I'm going to do 15 plus 17 first. But that's not the easiest way to do it. So the book would rewrite it, putting parentheses around that second set of numbers. Because who in here can tell me what 17 plus 3 equals? 17 plus 3, sir?
20.
20. Because 15 plus 20 is a lot easier to deal with. For the next one example here, we're going to do a multiplication example. 23 times 5 times 2. 23 times 5? Not my friendliest pairing. 5 times 2? I love it. So 23 times, I'm going to do the 5 times 2 at the beginning instead. Let's get 23 times 10 for 230. And the most common associative property I've seen for algebra simplification is 9 times 7x, or something like that, where I have a number multiplying with a variable that has a coefficient. So instead I multiply the number and its coefficient. I do 9 times 7, and then times x. So you get 63x. We got one more property, we're just going to put it on there real quick. Okay, distributed properties, this one gets distributed to the multipliers, or the add-ins, or the subtraction. So for this, if I had 26 times 4, I might instead do 20 times 4 plus 6 times 4. And I don't even have to write it out. I can just go, I'm going to do this times this, and this times this, to get 80 plus 24, 104. If I had 9 times 4 minus 3y, I can do the 9 times the 4. Oops, minus the 9 times the 3y. It becomes 36 minus 27y. So we'll deal with this a bit more on Monday.